Sure, vertical asymptotes. Good. Okay. So our vertical asymptote should be x equals -1/2, x equals 3. Somebody different, tell me how she got those. I'm going to keep asking you these same questions so you're able to do it on the exam. So how do you determine vertical asymptotes when you're looking at a function like this? Holly? Good. Setting the denominator equal to 0, and that means when there's multiple factors in the denominator, you're going to have multiple vertical asymptotes. Okay? All right. Horizontal asymptotes. Yes, Hannah. Okay, so Hannah got y equals 3/2. Okay. Somebody tell me how she figured that out. What do we look at when we're looking to discover if we have a horizontal asymptote and figure out what it is? Right? Good. Okay, so she determined it specifically from the coefficients. If everything was all multiplied out here, the lead coefficient here would have a 3 in front of it, and the lead coefficient in the denominator would have a 2 in front of it. How come she was just able to take the lead coefficients? Because we can't do that every time, only in specific circumstances. So what is the circumstance when we're allowed to just take the lead coefficients and say that's the value where our horizontal asymptote is going to be? Stephen? Good. When the degree of the numerator and the denominator are the same. So in this problem, you might have thought they were different the way they've written the problem, but think about if it was all multiplied out. What would be the highest power of x in the numerator? Good. You'd have an x squared up there. And in the denominator, you also have an x squared. And the 3/2 is coming from the numbers that would be in front of those x squareds when you put them together. Okay? So we took the lead coefficients. We were only able to do that because both the numerator and the denominator had the same degree. Okay? Since we have a horizontal asymptote, what does that mean about our oblique asymptote? None. All right, somebody new. X-intercepts for this problem. So where is the graph going to cross the x-axis? Holly? Good. So our x-intercept is 0 and +1. X-intercepts are actual points that we plot on our graph. They always have a y-coordinate of 0. So when she says 0 and +1, it's 0, 0, and +1, 0. So remember that asymptotes are lines. X equals if they're vertical, y equals if they're horizontal, and kind of a y equals mx plus b looking thing if it's oblique. X-intercepts are points on your graph, so points that we would list that we're going to actually see cross on our graph. Okay? All right, so then you should have taken all this information and put it on your graph. So you want to mark all your vertical asymptotes with dashed lines, horizontal asymptote or oblique asymptote with dashed lines, and then you want to put your x-intercepts on the x-axis. So go ahead and do that now, and I'll do the same thing up here. Yeah. I know some people got this far yesterday because I had looked at some people's paper. If you didn't, now you're with us at that point. Yeah, Alexis? How I got the numbers or how I put it on the graph? The graph. So horizontal is going to be a horizontal line. So 3/2 is like 1.5. So I just put it at a height of 1.5 and put it across it. Okay. All right, so remember what we want to do now is we just kind of want to fill in different curves in each section of our graph. And the way that we sectioned it off was the things that divide up the x-axis. So basically vertical asymptotes and x-intercepts. So we did kind of this little chart thing where we took kind of a snapshot of this is our x-axis. It's being split at -1/2 with an asymptote, 0 with an intercept, 1 with an intercept, and then 3 with an asymptote. And I basically want to just know in each of these sections a thing that's positive or negative, telling me should it be above or below the x-axis between these two barriers. Okay? So first thing I'm going to do, I'm going to take my function and I'm going to plug something in each of the little areas or zones. So first zone I'm looking at is this area. So numbers smaller than -1/2. So like -4, -10, okay? Anything that you want that's smaller than -1/2, think about if you plugged it in. My personal advice, if everything factors nicely like this, I just think about plugging it into each factor. So if I plug -10 right here, 3 times -10 is a negative, right? So I just kind of keep track, like with each thing I would multiply. So that's a negative. When you plug -10 into this factor right here, do you get negative or positive? Negative. Oops. And then in the denominator, if you plug -10 in here, negative, and in here, negative. So basically, in the numerator, negative times negative would make positive. You can totally plug it in and do the whole calculation. I think this is a little bit faster if they have it split up for you in factors. Okay, but you can completely go through and be thorough with your calculation if you want. So I get that it's positive here. That means I expect my curve to be totally above the x-axis in the area that's to the left of -1/2. So from here over on my graph, I expect the graph to be above the x-axis. This is the x-axis. Okay? But because I have an asymptote here and an asymptote here, I kind of get this idea that those are supposed to show me where the ends of my graph go. So either the end of my graph is like here and curves up along this one, or here and curves down. So the reason I know it can't be this one that curves down, 2 reasons. Is there an x-intercept over here? No. So can I cross the x-axis over there? No. Okay. So that's kind of a hint it should have been up here anyways. And then secondly, we got a positive result right here. If I drew my graph here, these are technically positive because they're above the x-axis, but if it turns and goes down and follows this asymptote, all of these points down here would have negative y-coordinates. So they would totally break the rule that I just figured out for my graph. So that tells me I expect my curve to be totally up here. So I'm just going to draw a curve in that follows those asymptotes. James? Because in each section of the graph, it behaves that same way, unless there's another intercept that tells you it crossed to change from positive to negative. So the reason that we use the asymptotes and the intercepts is because those are the only places that something could cross the x-axis to change from a positive to a negative. If there's not an intercept, it didn't cross. And if there's not an asymptote, there's not a break. So they're going to have to behave the same in each section. Okay? All right, so then I need to plug in a number between -1/2 and 0. So again, I know that's kind of a pain in the butt because we're kind of thinking decimals or fractions. But again, it's a little bit simpler when you can just do it for like each little factor that's up here. So let's say we were going to plug in -0.2 or something like that because that's between -0 and -1/2. So when you plug in -0.2, or erase part of what I have. And then think about what each factor is going to look like. So 3 times -0.2 would be a negative because 3 times a negative will always be a negative. Negative something minus 1 will be negative. So here I have to think a little bit harder. If this is -0.2, 2 times -0.2 is like -0.4. But when you add 1 to that, does it end up being positive or negative? Positive. Okay. And then here, -0.2 minus 3. It's kind of nice when they're all negative. Okay. So then I look at how this would turn out. So the numerator would turn out positive, but the denominator would turn out negative, and a positive divided by a negative tells me negative. That means in the area from the asymptote to this first intercept, I expect everything to be below the x-axis, which means if my graph is supposed to follow this asymptote, it must be down here, because if it was up here, it wouldn't meet this requirement of being negative, right? Which means everything's going to be down here until it gets to that x-intercept right there, and then I have to look at what's going to happen again before I can finish it. So I would finish drawing this. I would go up to the x-intercept. I don't care if what you have is perfect, as long as it's in the right area. We're sketching. We're not really graphing exact points. So then I have to plug in something between 0 and 1. Say I plug in something like a half, or if you like to think about it as a decimal, 0.5. So we want to determine what's going to happen. So when you plug in 0.5, 3 times 0.5 will be a positive. 0.5 minus 1 will be a negative. 2 times 0.5 will be something positive plus some more positive. This is why I like not having to do the whole calculation. It's a little bit easier to just see if it's positive or negative. 0.5 minus 3 would be negative. So this is going to be a negative over a negative, which means positive. So that means between 0 and 1, the graph is positive. But it has to come back down to the x-axis and hit this point at 1. So what I know is there must be some kind of curve happening between the two x-intercepts so that it's above the axis but still comes back to the second one. How high or how low that curve goes, I don't expect you to know. That's not an expectation here. We're just making a sketch. So I would just go ahead and sketch something so that it comes back to there. Okay? All right, so then I have to know what happens at this point. Does it turn around and go up here? Okay, that would be if it keeps positive. Or does it come below the x-axis and go down here? That would be what happens if it's negative. So I need to know, is it positive or negative between 1 and 3? Okay? So I'd plug in something like 2. So go back through, plug it into each factor. So 3 times 2 would be a positive. 2 minus 1 would be a positive. 2 times 2 plus 1, that would all be positive. And then 2 minus 3 would be a negative. So a positive divided by a negative would end up being negative. So I know that when it hits this point, it's then supposed to go below the x-axis. So I'm going to go down below the x-axis, and I'm going to end up following this asymptote on this side. So it's going to curve out and then start following that somehow. Again, exactness, don't care. Just want your curves above and below in the right place and following the asymptotes at their ends. Okay? Holly? Well, 4 is past 3. So there's another divider at 3. So basically, when I plug in anything between 1 and 3, I end up getting this negative, and I would have to, because if I got a negative and then I got a positive, that means it had to cross back through the x-axis, but there's no more x-intercepts. So I know it either all has to go up there or it all has to go down here. So that's why I'm allowed to just plug in one number from there. But 4 will be different because when I plug in 4, it's past this divider, which means it could have a whole nother thing, okay? And let's talk about our expectation past 4. Let's say, or past 3. We haven't plugged it in yet, but do you guys expect it to be positive or negative? Positive? Okay, so what's your hunch why it would probably be positive? Okay, if you plug it all in, it's positive. Also think about the graph. If it's supposed to follow this horizontal thing, but it's also supposed to follow one of these vertical things, if it was below, it would have to go here, and then for it to eventually end up close to this line, it would have to come up and cross the x-axis at some point to be close to that line, right? Is there any other x-intercepts here? No. So I almost have, I'm almost positive that it must be up here if there's not another x-intercept there. But I can always plug in to make sure. So let's say we plug in a number past 3, like the number 4. Okay? This would be positive, and this would be positive in the numerator. In the denominator, both factors would also be positive. So everything ends up being positive, which, like I thought, this would go up here. And again, if I've done everything correctly, it wouldn't have made sense for it to go down here because there's no place for it to cross the x-axis, which would make it impossible for it to get close to both of those asymptotes. Okay? All right. Is this all right with everybody? Yes. Okay, Kevin? So we set each of the numerator factors equal to 0. So when we set this equal to 0 and solve it, we got x is 0. And we set this equal to 0, we got x is 1. But in x-intercepts, they're on the x-axis. So these are the numbers we got from solving the factors. These are always going to be zeros because that's the only way to get them on the x-axis. Holly?
I have a problem with deciding whether it's horizontal or
Okay, perfect. So we're going to go through the next one. And the next one, we're going to set up all the asymptotes together, and then you guys are going to try to do the graphing together. Because I feel like you guys are getting good at this part of it, but we've only done this part of it together, so it would be interesting for you to try one of that part on your own and see how close you can get to the sketch of the graph. So I want you guys to all get a sketch. If you're really not confident in your sketch, Do it like not on the graph you want to officially be your notes, just like do it off to the side what you think it looks like. And then when we go through it together, you can write the corrected one. But just so that you can see if you can do this by yourself and if you have an idea of how that looks over here. Because often when I'm telling you, you're like, oh yeah, that makes sense. And then when like I'm not telling you and you have to do it on your own, you're like, this doesn't make sense. Okay? So we're going to do this part together now and then let you guys do this part on your own. Okay? So we're going to go back an example to part B. But if you've just been doing them in order, it doesn't matter. These were all graphing. All right. So we're going to go through the asymptotes first, then the intercepts. And then once we have all that info, we're going to let you guys try to make the little chart, see where it's positive or negative, and then where the curves would go on the graph. Okay? All right, vertical asymptote. Can somebody tell us what it is and how they knew? James. Good. So x equals -3. I'm going to kind of be a stickler about the x equals and y equals because the thing is mathematically, I get that you guys are saying the numbers, but the lines are different than the points. And so if you just list numbers, it gets a little bit difficult. So x equals -3. Someone else tell me how he figured that out. Yeah. Good. Denominator set equal to 0. Okay, then let's skip to the x-intercepts for a minute. What would be x-intercepts of this graph? Good. 0. Okay. Somebody else, how is she figuring that out? Mallory? Good. To make the numerator 0. So if I set 5x squared equal to 0, I'll just get x equals 0. So 0 is the x-coordinate I figured out. The y-coordinate is always 0 because it's an x-intercept and it's on the x-axis. There was a hand up in the back. Yeah. If it's just a number with x squared, yes. And then let's talk about the situation. What if the x squared wasn't in the numerator? What if there was just a 5 in the numerator? Do you guys have any idea what the x-intercepts would be? No. So if you take 5 and set it equal to 0, can you solve for any x value? No. So if there's no x's in the numerator, there's no x-intercepts that it can cross. Okay, so just to make sure in case you come across that situation. All right, so let's answer Holly's question about horizontal asymptote versus oblique asymptote. So first of all, it only has one or the other. So if you can find a horizontal asymptote, you don't have an oblique asymptote. But if you don't have a horizontal asymptote, then you need to go find the oblique one. So the first thing we do is we start looking for the horizontal asymptote in the 3 situations that we talked about before. So remember, there were 3 cases. Either the higher degree was in the numerator, the higher degree was in the denominator, or they tied, okay? I don't know. Whatever. Just writing it up. You guys get the picture, okay? So when the higher degree was in the numerator, there was no horizontal asymptote. That's when you need to go find the oblique one. When the higher degree was in the denominator, where's our horizontal asymptote? At y equals 0 all the time, okay? And then when they tied, how did we figure out where our horizontal asymptote was then? We just did it in the last problem, was it? Good, yeah, divide the coefficients, right? Just take the lead coefficient. So it's like whatever this number was over whatever this number was. It's going to change all the time, depending on the numbers in the problem. And those would be like something like this. Since these are the high parts, you're taking those coefficients, okay? So if they tie or the bottom, the denominator has a higher degree, we have a horizontal asymptote. When the numerator has a higher degree, we don't. That's when we need to go find an oblique asymptote. So does this equation have a horizontal asymptote? No, okay? Because the degree in the numerator is 2, but in the denominator only 1. So we say no horizontal asymptote. Then we need to go and find the vertical or the oblique asymptote. So the oblique asymptote requires division. So we need to take what's in the numerator and we need to divide it by what's in the denominator. Okay? So we have 5x squared being divided by, and I don't want to write it as 3 plus x. I kind of want everything in nice order so everything lines up right. So I'm going to write it as x plus 3. Okay? We talked about before putting zeros in to hold places of things that you might need. So this has x squared, but it doesn't have a term with x, and it doesn't have a constant. So in case those things show up, I would just put zeros in those spots again. All it does is make sure that everything I write down on my paper lines up exactly where it's supposed to be to help me avoid confusion later on. Okay? So remember the division process. You ask yourself what times x would make 5x squared. So that would be 5x. Okay? And then you're going to actually multiply it through what's here. So 5x times x is 5x squared. And 5x times 3 is 15x. This is why I put those placeholders. See how everything then lines up nicely? Okay. Then what do we do with this once we've multiplied it? Subtract it. And remember, we said the quickest way to do that is to go through and change the signs of all of the terms in that expression you just wrote down. Okay. So what should happen every time is then those should cancel. And then you have this to deal with. So 0x minus 15x is negative 15x. You don't really have to bring down the 0. Again, I just like everything to line up nicely to avoid confusion. And then I just start the process over again. What would I want to multiply times x to make negative 15x? Negative 15. And then I go ahead and do the multiplication. So negative 15 times x is negative 15x. And negative 15 times 3 is negative 45. And again, I'm subtracting those. So quickest way to do that, change all of these signs here. Okay? These should cancel. And here we have our remainder because there's nothing left to bring down. So the actual answer to the division problem is this with a remainder. But we talked about for our purposes, when we're just trying to see what's happening at the ends of the graph, the remainder doesn't matter at the ends of the graph. So we just use this other part to build our equation. Okay? So there was no horizontal asymptote, which meant we knew we had to go get an oblique one. To get an oblique one, it meant we had to divide, and we just care about the part of the quotient without the remainder. Okay? So our oblique asymptote is y equals 5x minus 15. I've already done this problem, so I'm going to give you guys a hint on the graph setup, and then I'll let you guys figure out where the graph is. No, so you don't divide everything by 5 or something like that, okay? So no factoring anything out of it, because then you're technically changing it. Like if I divide this by 5, it's like I'd have to divide this by 5 too, so that would look a little bit different than how I want it. Okay? All right, so graphing setup, okay? To put all of our asymptotes on here, let's go ahead and put our vertical asymptote at x equals negative 3. And we can put our x-intercept at 0, 0. Our oblique asymptote is going to kind of be a pain in the butt. Because the thing is, so you guys are used to the graphs looking like this. And then like our curves tend to follow them like this, right? Now with an oblique asymptote, what's going to happen is you still have a vertical one, but you're going to have something going like this. So you might have parts of the graph going like this or like this. Because now they're following that slanted line instead of the horizontal asymptote. So the thing is, wherever you put the oblique asymptote, the bummer is because it's slanted, it might go way down or way up, and you need to be able to graph on both sides of your vertical asymptote. So the issue here, graphing this line, what is the y-intercept in y equals 5x minus 15? Which part of this equation of the line is the y-intercept? Negative 15. It's like somewhere way down here, and then it wouldn't have even crossed this yet. Like, how am I going to get the graph on the other side of it if it's below it and not above it? So my advice to you in this problem, because we've already done it, let's number our y-axis by 5s so that every mark on the y-axis is 5s. But we're going to keep our x-axis by 1s. That's totally okay. And then let me tell you on exams how I would do it. On exams, I'm going to assume everything is numbered by 1s. If you want it numbered some other way, do exactly what I did. At one of the marks, mark what you want it numbered by, and then I'll go, oh, they're numbering by 5s or by 2s or by 3s or something like that. Okay? So now I'm going to go ahead and put this oblique asymptote on the graph, 5, 10, 15. So here's my y-intercept of negative 15. My slope is 5, which means rise 5, run 1. On my graph, that looks like 1 and 1 because my y-axis is measured by 5. So there's my rise of 5 is just going up one line. And then my x-axis is measured by 1. So up 5 over 1 looks like this. And that's okay as long as you have it labeled correctly on the graph. Okay? So this is going to keep going like this. And then what you need to do is you need to see it cross the vertical asymptote so you know what's happening there. So I need lots of points because I can't draw a straight line like you guys can on your paper, so sorry. Okay, so there is my oblique asymptote. Okay. All right, so what you guys are going to do right now, you're going to go and do your analysis. Horizontal asymptotes and oblique asymptotes don't divide up the x-axis, okay? Therefore, the height of the graph at the ends. So all you care about dividing up your number line are vertical asymptotes and x-intercepts. So in this case, you don't have very many. You have a vertical asymptote at negative 3, and you have an x-intercept at 0. So you want to decide, is it positive or negative here, positive or negative here, positive or negative here. So you only have 3 sections. Once you've looked at what that says, positive or negative, see if there's any way you can fathom what this graph possibly looks like to follow the vertical asymptote and also the oblique asymptote. Again, you're kind of taking I want everyone to try and just get a sketch. If you feel like you're totally wrong, sketch it in a place that you don't want your final graph to be, and then you can put it where you want it to be later. But I want you to think through it. It'll help you so much more than if you just follow me do it. Okay, if you just keep following. Okay, analysis. So, again, we don't include oblique asymptotes in our analysis. So I'm going to say what I said yesterday. I don't know if you remember I said it or not. On the test, there will be a question about what horizontal and oblique asymptotes represent versus what a vertical asymptote represents. Okay? So a vertical asymptote is a complete divider of your graph. It is a place where the graph is undefined. It is an x that you are unable to plug in. Okay? Horizontal and oblique asymptotes are only there to tell you how the graph is going to behave at the very ends of the graph. Okay? So oblique asymptotes and horizontal asymptotes just to describe behavior at the ends of the graph. Though the graph also follows vertical asymptotes, they are there to divide up your graph because you are literally not allowed to plug in those x values because they don't work when you plug them in. Okay? All right, so our analysis doesn't include horizontal and oblique asymptotes, even if they cross the x-axis, because they are not dividing up the x-axis. Only these things are, because this doesn't necessarily mean anything hits the x-axis. All it means for the oblique asymptote is that the graph has to eventually follow that. So our analysis only includes vertical asymptotes and x-intercepts that divide up the sections that could be positive or negative. So what did we get for things smaller than negative 3? Positive or negative? Negative. Okay, so from here over, our graph has to be negative. Now, before I even did that, what I would know is that the graph would end up either going up this asymptote or down this asymptote. Which one of those do you have to choose now if you know that it's supposed to be negative on the left side of negative 3? Down, right? It can't be up here. That would be positive, so it doesn't make sense. So definitely it has to be here, okay? Then because it's supposed to follow this other asymptote, my guess is it must just come around somewhere and turn around and be curved in there like that. Okay? There are no x-intercepts over here, so there's no way it comes up and hits the x-axis. It's all negative, so it shouldn't go above the x-axis. Those are my hints that it should be down here. And again, once I know it should be above or below, I go find the asymptotes and I try to follow them. Okay? All right, so then on the other side of the asymptote at negative 3, again, either your graph is up here following it or down here following it, okay? And then somehow coming over here to hit this intercept at 0. So the question is, between the asymptote and the intercept at 0, is it negative or positive so I know if it's down here coming up to 0 or up here coming down to 0? So it's positive. So that means this cannot be, right? it must be up here. And that means the whole graph is positive. All that means is above the x-axis. It doesn't mean going up or anything. So I just got to draw everything above the x-axis, which means it must go up the asymptote, but I need it to come hit the x-intercept. So I would draw this curve here. So it hits the point I know it's supposed to hit. It follows the asymptote on one side, and in this case, the positive side because it said positive. Okay. All right, then at this point, the question is, does it now go below that x-intercept, or does it stay above that x-intercept, and then somehow at the end of my graph, I have to come back and follow this line on one side or the other because that's the end behavior of the graph. Okay. So past the x-intercept of 0, did you get a positive or a negative? Positive. So should I cross all the way through 0 and go down below the x-axis, or should I just turn around at 0 and stay above it? Turn around, because I have to stay positive. So I know it's going to go up here somewhere. Where to go? Well, just draw a curve so that you end up following your asymptote. So I'm going to draw something so that it ends up along this line. So I would just curve it around so that it follows that line. Okay? So it's okay with everybody getting used to this process? So we just find those things at the beginning. We do this little chart and do our best to kind of place everything where it goes. Okay? So what's the one thing that we haven't seen show up in any of our graphs? A hole. So we're going to do one example with a hole and then let you guys work through the rest of the stuff on the note guide, okay? So, all right. So here's an example of a function that would have a hole. How do I know by looking at it that it's going to have a hole? Yeah, if I can factor and cancel some factor from the numerator and the denominator. So in this case, how does the numerator factor? So I would rewrite this function. And then you would rather graph something simpler than something more complicated, right? So the less things involved, the better. So definitely simplify it. So 2. I mean, I'm really just graphing x minus 2. Do you guys know what shape x minus 2 will be on the graph? A line, yeah. Mx plus b, it fits the form. So it's actually really, really nice. I'm really now just graphing a line, which means do I have to worry about all this asymptote stuff? Not really, okay? But the minute you cross out something from numerator and denominator, that should lead you to go down in the information part of the function and immediately want to label a hole. If this doesn't happen, then the hole would always say none. There aren't any, there aren't any, there aren't any. The minute this happens, you have a hole. What you want to do is you want to say which x value your hole occurs at. So my hole is at x equals, and it's whatever you would get if this factor was set equal to 0. So the factor I canceled out was x plus 2. If that was set equal to 0, I would get that x equals negative 2. So that's the thing that if I plug it in, it makes both the numerator and the denominator equal to 0. That's a really weird situation. That's why we're getting a hole on our graph. Okay? So the hole is at x equals negative 2. Okay? So here, as far as the asymptotes, vertical, because after you've simplified, no denominator. Okay? Horizontal asymptote, if there's no denominator, the numerator is definitely winning in the degree. So there's none. Normally, if there's no horizontal asymptote, we go find the oblique one by dividing. Is there anything for you to divide here? No, this is kind of silly. Asymptote is the actual line because it's simple. It's just a line. So what's it going to look like at the ends? It's going to look like the line it actually is. Okay, kind of weird. And then x-intercepts, you still technically have a numerator, okay? It's the denominator that has been completely canceled out. So where is your x-intercept going to be? At 2, 0. When would this be set equal to 0? Okay. At 2, 0. So again, I got that by taking the numerator, which is all that's left of the function, and getting this. Okay. When this happens, you're literally just going to go and graph your line. Okay. You already found the x-intercept, so if you want, you could put that on the graph. You could use that if you wanted, and the slope from there. Or you could go back to the equation. Think y equals mx plus b. Little line review. And you guys have y equals x minus 2. What's the y-intercept? -2, and the slope is 1. Okay, so the y-intercept is -2. The slope is 1, up 1 over 1, up 1 over 1. As many points as you need to draw the line. Okay, you are literally just making a line graph right now. The only thing complicated about it is how the hole is going to end up. Again, I can't draw straight lines, so sorry. So there is my graph. The only thing that's missing from my graph is a hole, okay? Okay, most common error when putting a hole in the graph, putting a hole not actually in the graph. Like, no, there's a hole. Like, that's not even in the curve that we're looking for, okay? So that's not a hole in the graph. It's just a hole in some random place that you put it. So I'm going to explain how to do the hole, but make sure your hole should always be on your curve somewhere. It's some point on here that is actually getting erased and doesn't exist, okay? How to decide which point that is, look at where you decided that the hole was. The hole was at x equals -2. So look at the x-axis. Here is where -2 is. Do not put your hole on the x-axis at -2. Is that a point on this graph? No. But there is a point on this graph that lines up with -2, right? That's the point that needs to be erased. That's where the hole needs to be made, okay? So my hole needs to be made lined up with -2, but actually on my graph. So this point right there is the point that is being erased. And then in its place, just make an open circle so I know you understand, like, there was a point right here, and now it is a hole. Okay? So do we understand the hole doesn't go on the x-axis at the number that you found? It goes on the graph that corresponds, so it should be a hole in your curve. Okay? So whenever there's a hole, you should draw the whole thing that's left, just like we've been practicing, even if it's more complicated than a line, whatever curves. Then where your hole is, go to your graph and literally erase the point that lines up at that x value on the graph and make your hole. Okay? Does that make sense to everybody? Yes? All right, so how much time do we have left? 5 minutes? Yeah, you guys have 5 minutes. All right, so go ahead and try to graph this one before you leave, and I'll walk around and help you guys.